Hey, it's Naz from Naztronomy. What you just saw was my shot of Saturn this past weekend at opposition. I thought I would show you the results first, that way if you don't care about the rest of the content, if you don't care about the acquisition details, you don't have to stick around and comb through the video. But if you're interested in the acquisition details, stick around and I'll show you the equipment that I used to take that picture. Otherwise, thank you for watching. And if you're still here, I thank you for sticking around. This past weekend was the best time to look at Saturn because it was at opposition. But if you missed it, don't worry, Saturn will be visible well into winter. My previous best image of Saturn is this shot from June 2012. This was a single image, not stacked, and barely processed in Photoshop. I was new to the hobby and knew very little about how to process anything. This past weekend was the first time I was able to image Saturn at opposition, so it felt a little bit more special and I wanted to process and share it with the world. To catch Saturn, for my telescope I used my Celestron Nexstar 6SE SCT. It has a native focal length of 1500 millimeters with a focal ratio of f10. I added a 3x Teleview Barlow and a ZWO ADC to the imaging train. And I used a stock DSLR to shoot a whole bunch of 1-minute videos of Saturn for stacking purposes. This Teleview 3x Barlow gives my SCT an effective focal length of about 4500 millimeters, which means it turns the focal ratio from f10 to f30. It's incredibly slow, but for the purposes of capturing a bright planet like Saturn, it's perfect. And the next thing on the list is the ZWO ADC, short for Atmospheric Dispersion Corrector. I'm borrowing this, so it was my first time using it this weekend. It was also my first time using the Teleview 3x Barlow, so I was happy that I was able to use them both successfully. The ADC helps correct some of the distortions and the dispersions we see due to the atmospheric movements in front of the planet, on our own planet. I put all of this equipment on my AVX, did a rough star alignment so that I can do tracking, and centered Saturn in my eyepiece and stared at it for about an hour before I moved to imaging. Mentioned earlier, I took videos of Saturn. Each video was between 1 and 2 minutes each, mostly 1-minute videos. So this is one example. You can see that the planet isn't sitting still. That's because of the movement in the atmosphere and the imperfect tracking out with my mount. While my DSLR was recording, I just stared at the LCD screen standing in my driveway for a while. Once I was done, I moved the video files over to a software called PIP, AutoStacker, and then Registax. I'm not going to cover how to process those in this video. I'll cover that in the next video because I don't want this video to get too long, and the processing steps can take a while. And to keep that video short, I'll only be working with one of those video files, but once you take it back with you, you can add as many of those video files as you want, as long as you're not showing any rotation in Saturn, at which point you might get errors. This is more of a problem with planets like Jupiter because the bands are so much clearer to see, the big red spot is there, they move, and Jupiter is the fastest spinning planet in the solar system. So to learn the processing steps, come back, watch my next video, and I'll explain everything there. And the last thing I'll mention about the results that you saw, and what I'll show you again, is that I didn't take just one single 60-second video to do the processing because I had a lot more time on my hands. I took about 15 minutes worth of videos. So it's about 30,000 frames. I took the best 10% of those frames using the software and I stacked those. So it took much longer than what you'll see in the processing video, but it was well worth it. Thank you for watching. If you have any questions, please ask. Until next time, clear skies.